I'm going to show another astronomical technique. This one's a little bit different from anything that most people have probably looked at. What I'm going to do is take the distance differential between two planets. In this case, I'm just going to choose Mercury and Venus and apply it on a soybean chart. So what I'm doing, you can see on the galactic data sheet, we have the distance column for the planets. So we have the sun distance in AUs, which is astronomical units. Astronomical unit, I think, is just how long it would take in years to move from the planet to the sun at the speed of light. In this case, using the galactic data, this data is based off of the galactic grid. In the galactic grid, the center of the sphere is the center of the Milky Way galaxy, which is in the constellation of Sagittarius. So we're going to compare these measurements of these planets inside the galactic grid. And then I'm going to do another one where I'm going to use the AUs of the planets to the sun on the regular astro mapping and make a comparison between those two. So the sun is there, Mercury distance in AU here, the Venus distance is here. So what I've done, I've copied and pasted all the distances of all the planets to another sheet, and then I did a summary here in column M, and all I did was add the Mercury and Venus columns together and then divide those by 2. And then I looked for the minimum and maximum points when I went through those differentials. So what we're doing, we're actually using the distance of each planet to the sun, but we're adding those together and dividing by 2 to get the average between the two planets, and then we're looking at the minimum and maximum distance as we go through time to see what those differentials are. So looking at column M at those differentials, I've got a minimum here on 1220 would be the first one I have. And I manually go down, and now we're looking for the next one, which would be the maximum. That would be at this point right here on 227. Then we've got this right here, this minimum on 413. Then we've got this one here on June 14th, August 18th. This one should be 929. I highlighted the wrong box. Then we've got one on 12/7, and then the last one we have currently is January 18th. So let's go take those to the chart and see what happened. So I've listed the dates here and marked those points with arrows. You can see Mercury and Venus average distance differential. We've got 1220, 227, 413, 614, 818, 929, 12/7, and 118. The first one, 1220, was one day after this high. The next one, 227, was this little spike high right near this bigger bottom. Got a couple days down after that. The 412, 413 was the weekend. The high came the 12th on Friday. Then we have June 14th, one bar after the high. 818 is this big low here. The low is on the 16th. We had the weekend, and Monday was the 19th. Then on 929, we were on the weekend. That was Sunday. We had this two highs together on the 27th and 30th. 12-7. We had the weekend again, the 6th and the 9th. We had the high on the 9th before that good push down. And then on January 18th, we have another weekend and holiday, MLK Day there. So we've got this reversal on the 17th pushing upward. So this is another technique, pretty simple. You can experiment with different planets and try this out. I know Mercury and Venus effective on soybeans from all the Bayer work, but this is a good one to experiment with, just to reinforce that we're not actually